Hello, welcome to all our viewers. I'm Maria Stanford. Today we're gonna talk about what if humans were to live on Mars? What do you think? Do you think our bodies would undergo several changes due to the unique conditions of the red planet? Here we go. Mars has a significantly lower gravity compared to Earth. Mars has approximately 38% of Earth's gravity, which would have a profound impact on our bodies over an extended period. The reduced gravity would result in muscle and bone loss since our bodies would not experience the same level of stress and load-bearing as on Earth. Astronauts in space already experience muscle atrophy and bone density loss due to microgravity, and living on Mars would likely exacerbate these effects. The reduced gravity on Mars would affect our cardiovascular system. The heart would not have to work as hard to pump blood against the lower gravitational force, leading to a potential decrease in heart muscle mass and overall cardiovascular fitness. This could result in a decrease in cardiovascular performance and an increased risk of orthostatic intolerance. Mars' lower gravity would have a significant impact on our skeletal system. Without the constant pull of Earth's gravity, our bones would experience reduced stress, leading to bone mineral density loss and increased susceptibility to fractures. Over time, this could result in osteoporosis-like conditions, making our bones weaker and more prone to injury. With the decreased gravitational force, our muscles would gradually lose mass and strength. The body would adapt to the lower gravity environment by reducing muscle tissue since it is not needed as much for movement and support. This loss of muscle mass, known as muscle atrophy, would impair physical performance and could lead to decreased mobility. Circadian rhythm. Mars has a day length, SOL, of approximately 24 hours and 37 minutes, which is slightly longer than Earth's day. The difference in day length could disrupt our circadian rhythm, the internal biological clock that regulates sleep-wake cycles and various physiological processes. Adapting to the Martian day-night cycle would require adjustments to our sleep patterns and could potentially lead to sleep disturbances and other related health issues. Mars has a thin atmosphere and lacks a protective magnetosphere like Earth, which means that it offers less protection against harmful solar radiation. Long-term exposure to radiation could increase the risk of developing cancer and other radiation-related health issues. Protective measures such as shielding and habitat design would be necessary to minimize radiation exposure for human settlers. The atmosphere on Mars is much thinner compared to Earth, with predominantly carbon dioxide, CO2, and very low levels of oxygen. This would require breathing assistance and oxygen supplementation for humans to survive. Over time, living in a low oxygen environment may lead to respiratory system adaptations, potentially affecting lung capacity and function. The Martian environment is vastly different from Earth, and human settlers would be exposed to new pathogens and microorganisms to which they have no prior immunity. This could lead to an increased risk of infections and challenges in maintaining a healthy immune system. Stringent hygiene practices and well-controlled habitats would be crucial to mitigate these risks. In conclusion, living on Mars would have significant physiological effects on the human body. The lower gravity, radiation exposure, altered sleep patterns, and atmospheric differences would result in muscle and bone loss, cardiovascular changes, respiratory adaptations, and immune system challenges. These changes would require careful planning and countermeasures to ensure the health and well-being of human settlers on Mars. Hope you all are enjoyed this video. Have a nice day. See you next time around. Maria.